Hello, good evening. Welcome to Real Learning Center. So, we are starting a new series of PUC, second PUC physics class. So, let's call this as physics simplified. It means our main aim here is to make physics as simple as possible to understand. So, I encourage all of you to write down any of your doubts or anything that you have in the chat feed. So even when after the class, even when you watch this live or even you watch the recorded one, you can keep reading the chat so that I will try to answer your questions as much as possible. And if you also need, there is one more thing I want to dedicate this mainly for people who are in the PUC, that is Karnataka PUC, and hence I want to basically make it simple for all. Simple means sometimes what happens is people who take classes from various places, they may find some of the English also difficult. So I try to do it in simple English as much as possible. However, if you want it in Kannada, some things I will try to explain it in Kannada too. But I want you to give your preferences. If you want me to talk some parts in Kannada, I will be able to talk. But all the technical words, everything will be in so joining words may be in Kannada. I hope you will be able to understand well. So we are going to start the physics from where the beginning is. That is the first chapter. First chapter of the physics, second PUC. So we are starting in second PUC. First chapter, we call it as electrostatics. Okay, in the sense that electric charges and fields. That is the name of the chapter. So we will spend a little bit of time trying to understand this chapter. First of all, what is the meaning of understanding? Okay. So I will tell you something which is very interesting when we are studying science, but to others. Okay, when you are for example, reading a story, you will find out who are the main characters. So only those characters are basically important to you, and you will keep following those characters. Like that in science, we very rarely do. Even in science, there are many good characters, not actually people, but some concepts. And if you follow them uh, closely, you will start liking the subject and understand. So I am going to introduce some characters in the electrostatics or electric charges and fields. So the name of the class is electric charges and first chapter in the textbook, use the textbook, second. So let us see who are the main characters. Okay, in the first two chapters. In fact, in the first two chapters, who are the main characters? Okay. First character, we call it as electric charge, is the hero of our story. Electric charge is the hero of our story. Okay. If you understand electric charge well, the whole story runs very smoothly. Okay. So the next person in our story is electric. So after electric field, we have then third one, what we call is electric dipole, and fourth one is electric flux, and lastly electric potential. Actually, if you study these five, if you try to understand these five very well, then first two chapters. So how to understand these five? That is where we are going to start our discussion. Yes, the let us go with first understanding what is the meaning of electricity. So let us start with a simple question saying that what is a charge? What is the so you all have heard about the word charge, correct? In English there is a word charge. So charge means what? He is in charge principal. So that means he is actually not a principal. He is taking the charge of the principal. Okay. So or we can use it in other in various other scenarios. Like we will say, I am charging my phone. That is another place where you use the charge. Correct? And the police charged and beat up the thief. So we use another. So there are many meanings with which we use the charge. Okay. And there is very interestingly, the word charge has similar aspects in all these meanings, which is basically something that has come on top of it. Like you assume the charge of the principal. What does it mean? It means you take that role, okay, you take some responsibility, you are made in charge. So something which is not there in you, you have taken it upon yourself. That is a charge. And actually speaking, my phone is out of charge. That is the real electric charge that we talk about. It is out of electric charge, your battery. That is the real charge. So here what we talk about is something. Now let us say you take, for example, one proton or an electron. You must have heard about those things in your chemistry also. Let's say you have a electron. The electron is one small particle. It has some mass. Mass means it has basically some stuff in it, and it has some charge. So that means it has something in it which makes it very different from others. Something it has taken upon itself. That's called charge. Okay. And we don't know actually. There is no other way to explain charge. Charge is a very fundamental. So you cannot say charge means it is made up of these things. We cannot say. Charge means it is just one. So that is basically what it has. It's a fundamental property. So electric charge actually is a fundamental property like mass. So we say that electric charge is there in on electron. Electron has a negative charge. Electron has a negative charge. And then we say proton has a positive charge. So we use these terms negative charge and positive charge. Why do we use these terms? Why not just charge? That is because there are two types of charges. So the two types of charges are basically how why are there two types of charges when long back when they were doing experiments, they figured out that there are two things that happen. One is attraction, the other one is repulsion. So if you take for example uh, a balloon, take one a balloon and blow it and take the balloon and rub it on your head, on your hair. So make sure that there is no oil in your hair and just rub it, dry hair. So you will see that the balloon acquires some charge. How do you know that it acquired some charge? If you take some pieces of paper, you can take the balloon near to that. It will attract. So it will basically attract those pieces. So that is, you can say that, oh, there is attraction. Now you take, for example, another balloon and that also rub it. So there are two balloons are there. One balloon you rub here, one balloon you rub here. So there are two balloons. And if you keep those two balloons here, one balloon here and another balloon here, both of them are actually blown and rubbed on your hair, and you will see that when you bring them near, they will be pulled apart, they will be repelled. So there are two things. One is attraction, another repulsion. Because there is attraction and repulsion, there are two things. There may be two kinds of charges. That is the idea our old days scientists have thought, that there are two kinds of charges. They could have named them as charges of type A and type B, but they didn't name them. They named them as positive and negative. Okay. So they could have named this one positive and this one negative, but they chose to put electron as positive and proton. That's okay, just arbitrary. It's like saying, why is this called left hand and this called right hand? You can call this as left hand and this as right hand. It's your wish. Want, but everybody calls it this as left hand. Like that. So that's called convention. We say it's a convention. Everybody follows this, hence it is a convention. Okay. So there are two kinds of charges. What have we learned? We learned that charge has two kinds, positive and negative. How did we learn that? Because there are two kinds of things that happen, attraction and repulsion. We say then that if there are like charges, they repel. Like charges repel, and unlike charges attract. How do we say that? How do we know that? Because we saw that when you take two balloons and rub it, whatever happened to one balloon, same thing happened to the other balloon. So they are like, they are similar, and they are repel. So two things which are similar are repel. So that's why we say like charges repel. Okay, but paper we didn't rub, and we rubbed only this. So hence paper got attracted. Paper probably has some negative charge, or it might have some way of carrying some negative charge. Okay, that we will explore later. So electric charge is about basically having something in it which is making it attractive or repulsive. Okay. So we understand that charge has two types, positive type and negative charge, and also two rules of the charges we understand. But are there any other properties? Like the charge is our main flow, correct? What are the things that he can attract some people? There are some two kinds of people are attracted, two kinds of people are repelled, all that we figured out from the electric charge. Yeah, but now we have to find out what other characters are there in the electric charge. What are the properties of electric charge? There are many properties. We will discuss only three properties, three most important properties. Okay, I am going to write down here three properties of electric charge. So they look like complicated, but they are really not. Okay, you can see that the properties are one. They are basically additive. You can add the charge. This is why you remember I told you that instead of calling them as type type A and type B, we call these charges as positive and negative. Why are they positive and negative? Because we can add positive and negative numbers. Charges can be added. This is the first property. So let us say I have three charges. One charge as +2, another charge as -1, another charge as -3, like this. You can ask a question, what is the total charge? Total charge. So they are all nearby. Total charge is how much? You ask. I can add them. See, it looks like it's not a complicated thing. You can always add, correct? So here also you can add. That means when you add two things, it behaves as though, see, this looks like a simple thing. Okay, if I have, let us say, one charge which is +2, another charge also +2. If you put them very nearby, they have to behave like a single charge that is +4. If that is the case, then we can say we can add. And another interesting thing that happens is that if I put one plus 2 and another charge as minus 2, if you actually add them, it looks as though there is no charge, because plus 2 and minus 2, when you add, it will become 0. So you can add charges. Here when you add charges, you get 2 minus 1 minus 2. This is minus 4 plus 2 is totally minus 2. So like that we can add, like algebraically you can. Okay, so that is the first property. You can add, so which is not a very complicated property. You know that things can be added. Here also you can add property number. Let us look at what is the property number 2 is charges are conserved. What is the meaning of this? Charges are conserved. So charges are conserved means, you know what is the meaning of conservation? You must have heard this in various other scenarios. Like you want to conserve water, you want to conserve forests, like that. There are a lot of conservation. Conserve means what? It will stay as it is. It should not be destroyed. That is the meaning of conservation. Okay. We can't increase it, but at least we should keep it as. So thing that does not increase, does not decrease, stays as it is called as conservation. Okay. So conservation is all about keeping things as it is. Okay. Now you see that charges are conserved actually means charges are neither destroyed nor created. They are not increased, they are not decreased. Let us say you have some charges 248 plus. Okay. Now this is some material has this many charges. Now what happens is that this charge you cannot take one become 247, 36 or 249, it won't be. It can be transferred though. So if you take another material and take some of them here, that means charges are like mass. They can't be destroyed. They cannot be destroyed. That is a very interesting thing. And they can't be even created. New charges I cannot create. So they are either transferred from place to place, or they are either, or they will be constant. They will never change. You can only change, move them from place. So if you rub, for example, I told you that the balloon, when you rub it on your head, it gets charged. So what does that mean? That means basically some electrons, that is charged particles that are there on my head, are transferred to the balloon, or balloon transfers some electrons to my head. One of the two. When that happens, both my hair and the balloon, both of them get charged. So that is basically charging. By rubbing, you can see the charge. It's just transferring the charge and create a new charge. That is called charges are conserved. And the third one is a little more interesting to understand. Called charges are quantized. What is the meaning of this quantized? Is there a meaning to this quantized? So there is. Yes, what happens basically means is that if you look at one electron, the one electron has some charge. One electron is there. That electron I will call it as E. It has some charge. Let us say it has a little bit of charge. I'm going to write it as, uh, I will not write basically a huge number. Actually, it has a charge of 1.6 into 10 to the power of minus 19 coulombs. I'm not going to write that. I'm going to write that as 0.0 something like some number. It has that much charge. Another electron basically also has point. On proton, this is all negative. A proton is there, let us say, that is plus point. So I will give you any number of protons or any number of electrons. Now you have to create some charge. Let us say I want to create the amount of charge I want is 0.06. I can. How? I can take one proton 0.02, one more proton 0.02, one more proton 0.02. All these three things put together, I will make one basket. That basket contains three protons. All of them 0.02, 0.02, means basically 0.06. Fantastic, correct? Minus 0.04 means I will take these two and create it. Any number we can create, right? But some numbers we cannot create. For example, can you create 0.03? I will take one proton, it will become 0.0. If I put one more proton, it will become 0.04. I can't make it 0.03, correct? So because of that, what happens is that somewhere in between these charges that this is contained, we cannot actually create. We cannot create any value of charge, like 0.0315. We cannot create. We cannot create such charges. We cannot make such charges with whatever we have. We only have this our lowest unit is 0.02. So any integer multiple of 0.02 we can. This is called charges are quantized. Quantized means integer multiple of the smallest charge. It's called integer multiple of smallest charge. That's called quantized. Instead of quantized word, we can use it. Integer multiple of the smallest charge. So that is basically our charges are quantized. Now you can see that in our real scenario, I have taken an example of 0.02, but in our real scenario, it's not 0.02. It is, each one is 1.6 into 10 power minus 19 coulomb, which is a very small number, 0.0000000 like this, 16, some 8, 17 zeros. So such small coulomb, small charge will be there on. So all charges have to be multiple of this. What happens is in reality, in theory they are quantized, but in reality, when you are dealing with more amount of charges, we don't care about this charge quantization. If somebody says give me 2.3589 coulombs, we will give, because it is possible to create using this, because it's a very small number. Only because it is a very small number, it is small. Otherwise, charge is quantized. That is the another property. So these we have learned now many properties of electric charge. Correct? Charge is quantized is the third property. So if you are asked in your exams also, what are the three properties of a charge? These are the three. You also now today understood. Don't by heart it. Please understand what it means. What it means by adding the charges, what it means by charge conservation, what it means by charge quantized. So my goal is for you guys to be able to understand and write, not just by heart and write. I hope you are able to understand. If not, please write down what you did not understand in the chat and I will clarify it in the next. Okay, so let's move forward. And last property I will talk about the charge. Okay, we have now talked about three properties. Now we will talk about the force between charges. What is the meaning of force between charges? So we know that forces are there because either they are attracted or they are repelled. So by how much force? Okay, they are either pushed or pulled. How by how much force? That is the question. Okay. For that question, the answer is given by was given by a physicist called Coulomb. Coulomb gave a law called Coulomb's law, his name, which he did a lot of experiments to figure this out, the exact amount of force that is required. That happens when there are two charges. So Coulomb's law gives that. So we will now study what is Coulomb's law. So I will tell you basically what is Coulomb's law in a very simple term, and I'll also tell you it in a very formal term, like how in your exam there. Both I will tell you, but you please understand it in simple terms. Now, Coulomb's law of force is given as K into, so what we say is Coulomb's law is proportional. Let's not write K. Proportional Q1 Q2 by R square. What are these strange things? Q1 Q1 R. So let us say you have two charges. I said two charges, either attract or repel. Correct? So I'm going to have two charges. Charge 1, charge 2. Two charges. These two charges have a distance between them. Let us say 10 centimeters. Let's say one charge is 0.2 coulombs, another charge is 0.3 coulombs. Okay. Now there is a distance also between 10 centimeters. Now what we say is force is dependent on three things. How much is the first charge? How much is the second charge? What is the distance? All these three are captured. Q1 is this one. This is Q1. Q2 is this one. Q2. And R is this. Then, but please remember that this is a proportionality. What is the meaning of proportionality? I will tell you. So that means if you actually make this force, this charge, let us say twice what it is, it would be. Like in this case, for example, this is 0.2 and this is 0.2. Now instead of this, what I will take as, let us say everything else I keep constant. Okay, this will become 0.4. The second one will remain as 0.3. Q1 has become doubled. Q2 remained as it is. Okay, R will basically remained as it is as 10 centimeters. Now look at the case 2 cases. This is case 1. This is case 2. Okay. Now in case 1, let us say we calculated the value of the force. Okay. Let's say force F is equal to some 2.753 newtons. Force is measured in newtons, some newtons. We don't know how much. I will call it as X. X. N is the force or force. X. So this is in case. Let's take case 2. Case 2, what have we done? Look at this. In case 2, we kept everything as it is. Q2 is as it is, R as it is. Q1 only we changed it from 0.2 to 0.2. That means Q1 we have doubled. So Q2 same, Q1 doubled, R same. So only one extra 2 has come. 2 into Q1 we have. That means basically force is going to double. If you double any one of them on the numerator, force is going to double. If you make any one of them in the numerator 0.5 times or 0.6 times or 0.2 times or 1.2 times, anything, any multiplication factor you keep, that will be coming to the force. So force will become 2x, it will double. Okay. On the other hand, if I take case 1 to be this one, 0.2, case 2 also same. Okay. However, I will double the distance to 2.3 only. I will double the distance. So 10 centimeter distance becomes 20. So what will happen? So if you look at this, now case 1, we will look at case 1 and case 2. Case 1. So case 1 is as usual, let us say some x, any value for x is calculated. So please understand that I am not going to do calculation because I will do numericals separately. I will take a class where I will take interesting and important numericals and I will solve them. So now we will not spend too much of time on arithmetic because you will find it difficult to multiply, add, subtract, divide and all. So let's just use x, y, z, that kind of a variable. Easy to understand. So f is equal to x. Now let us see here what happens is how did we get x? Because q1, q2 and r square. Now for this f, q1 is same one. Okay. No change in q1. q2 also changed. R has become double the r. 10 becomes 20. Correct? So double r. So we will write it as 2r square. Denominator contains the distance between them. And distance has doubled. So we will square it. So now what happens is this will be nothing but q1 q2 by r square and this is 4. 2 square is 4. Right? So if you see this whole thing is remaining originally f. Case 1's f. So this is 1 by 4 into case 1's f. So since I have doubled the distance, force has become 4 times less. 1 by 4 times. If I double the distance, force has become 1 by 4 times. Similarly, if I halve the distance, instead of 10 centimeter, I make it basically uh, 5 centimeter. See, this is the meaning of inversely proportional. When I decrease it, force increases. When I increase it, force decreases. So that is why we see now I have increased it by double distance. So force has decreased. It became 1 by 4. So 1/4. Whereas here, if I decrease it, then if I make it half of it, double. Not double. No, 4 r denominator will become 0.5 r whole square, which is 0.04. Okay. 0.5, 0.25. 0.25, basically take it upwards, it will become 4 times. Okay, like I will just do it and show it. In the case of I am making it basically half of it. Half is 0.5 r whole square, which means basically q1 q2 divided by 0.25 into r square. 0.25 is what? 1 by 0.25 is 4. So you halve the distance and became 4. So this is how inversely proportional means. Now this is what is our Coulomb. Coulomb's law, he doesn't tell about exactly what is the force. He tells only about relative changes. If you double this will double. If you double this, it becomes 4 times less. If you make it 3 times more, this will become 3 times more. If you make 3 times more, this will become 9 times less. Square times. This is what he is telling by making this statement. Coulomb's law only says that much. But whenever there is a proportionality constant, we can replace it with using a equal to. When you replace it being an equal to, then we will actually be able to exactly give the value. But that proportional constant has to be experimentally measured. Experimentally, we have to measure it. Okay. So in this case, what happens is this whole statement will become f is equal to k into q1 by r. So now we replaced proportionality constant with a value k. This k is experimentally measured to be 9 into 10 power 9. That is the value. It's also actually written, k is also written in a slightly different way. K is equal to 1 by 4 pi epsilon naught, where epsilon naught is 8.85 into 10 power minus 12. Those things you can Google and get 4 pi epsilon naught. And this value, epsilon naught, is called as, read this as like, this is the epsilon and this is 0. So read it as epsilon naught. Naught is 0. Epsilon naught. You can call it as permittivity of free space. What is it? What is this dangerous thing? Permittivity of space. You don't have to worry. Yeah. It is just a constant for free space. And another day we will worry about it. We're going to next week. Okay, till then you can't, don't worry about it. Just call it as some constant. It is given by certain value. Okay. So remember, this k is easier to remember. 9 to the power. Now, when we do the numericals, this will come in handy. So this is what we call as modulus of x f vector. It's a very interesting statement. You have learned vector the last year. Vector means some parameter, something has both properties of, has both magnitude and direction. So that means basically you are asking a question, how much and in which direction? Two questions are asked. How much and in which direction? How much means this is answer. In which direction? We have not given the answer. Yeah. Force is basically a vector. Force is a vector. So we have to be able to tell what is this. See, force has two things, magnitude and direction. What is its direction? It is in which direction? Okay. So let's then have to have some kind of a convention. So this is one, let us say this. There are two objects. Okay. So I will call this as distance between them. I will call this as R1. R12 means from here to here as a vector position R1. We generally write it like this. Coordinate system xy, and we call this one as R1 and this one as R2 and this one as R1. So if both of them are of the same charge, like positive charge, if both of them are negative charge, in both cases they will repel. But repel in the sense what? The second one will get repelled in this direction. First one will get repelled in this direction. That means force acting on the two, force acting on two is from one. I will write force acting on two from one. Force on two because of, that's how I write. That is equal to k into q1 q2 by r square. That is the magnitude and its direction. For direction we always use unit vector. Okay. unit vector is in this direction. So it is repelled. So it is going this way. So it is in the same direction as R1. R12 cap. R12 cap means it is in the direction of R1. That's all it is. So similarly, F12 means force on 1 due to 2 is equal to same formula. But here it is R2, or we can write it as minus R1. Both are same. So we will write this as K Q1 Q2 by R square R12 minus. Therefore, F21 is equal to minus F21, and it's very natural because they are repelling. One is going this way, one is going this way. So they are opposing each. They are equal. So that's why it is minus. So this actually completes our full understanding of what is electric. What all we have done? We have done electric charge. Means what? Properties. And then we also discussed about Coulomb's law. That is all over. Okay. Our electric charge understanding as a concept is done. Yes, numericals we have to do. We have to learn basically how to use this formula, all the things. But as a concept, we have. Now we are going to get into what is the concept electric field. We will try to understand today electric charge and electric field. If you know these two things, in fact, first chapter is all about these two. In fact, it covers electric dipole also. But most important thing is, let us now understand what is electric field. So there is before going to electric field, there is one more interesting part that we need to understand. Is let us say I keep one charge here, okay, some charge, that 1 coulomb, 0 minus 0.2 coulomb charge. Now I'm going to trying to attract this side. How do I attract it? I put a positive charge. I'll put a positive charge plus. So let's say 0.5 coulomb positive. So because of this charge will try to come this way. But I will not keep just one charge. I'll keep one more charge. That is also plus. That is also 0.5. And that will try to attract it, pull it. So it is like basically the tug of war. You take one thread and pull both sides. You are in the middle, you are pulled on both sides. So this side it is getting pulled because of this charge, and hope that these two charges I am holding here. I am not allowing those two charges to. Okay? They are fixed. Those charges are not allowed. This charge is allowed. So when you have that, then what happens? It is trying to basically, this is trying to go this way also, this way also. So what will happen? If if these two forces are equal, then it will not go anywhere. That means the forces cancel. So that is called addition of vectors. So two vectors. This is one vector, this is another vector. So add them because they are opposite. So result will not. So this is how you can add the forces. And adding forces, just because it is electric charge also, you can still add them. Now if you have the, suppose if you have the electric charge not here, let us say you have one more electric charge here. This is also the point. Now it is pulled this way. One is pulled this way, another is pulled this way. Where will it go? So it will have to go somewhere in between, correct? So this is called vector addition for parallelogram law. So whenever there is a multiple forces, multiple charges are there, multiple forces are acting on the charge. So we will do some very nice numericals to understand this later. Okay. So now coming back to electric field. What is electric field? So electric field is like some people ask what is the magnetic field or electric field. And the answer is like this. Our when we were in 8th, 9th, then there is a magnet around that there is a magnetic field. Correct? So we assume like this. There is a magnet, then yes, and around this there is a magnetic field. So in our imagination, magnetic field is like a cloud around this. Correct? So if you keep an electric charge, positive charge, around that there is a lot of magnetic electric field is like a cloud around. So that explanation of electric field is like a cloud around the charge. No longer going to be valid. We have to understand it basically slightly differently. Here is the 12th standard. Second. So how do we understand it? What we do is simply we define electric field. Look at the simple aspect of defining. We are defining it in a slightly very simple way. It is the force acting on a unit positive charge. Force acting on a unit positive charge is called electric. That's all it is. So electric field is what? In the first place, electric field is a force. So field is a force. Electric field is not a cloud. It is a force. Electric field is a force. Okay? And the force that is acting on what? Acting on a unit positive charge. If I take a positive charge of 1 unit charge, 1 coulomb or whatever. Coulomb is a unit of charge. Electric charge. 1 coulomb or 1 small charge you take, and that charge, to keep it electric charge, what is the force that acts on it? And that force is called electric field. Electric field is nothing but the force. Remember this. Electric field is the force. This is one thing that you have to keep on remembering. Electric field is what? What kind of force? So, suppose if I keep one unit positive charge, one charge, what is the force exerted on? Let us say the force exerted. Why will there be a force on it? There will be a force on it only if some other charges are there nearby. Let's say here one charge is there, here one charge is there, and those charges are basically trying to pull it or push it. Some things are like that are happening. So here there is one positive charge, some 5 plus 0.5 coulombs. Here some negative charge, basically minus 0.02 coulombs. Something like that is there. Okay, and at this point P, here I have kept a charge. That is a unit charge, single, one unit. So when you keep it like that, this charge, what is it doing? This charge is basically repelling this, like this is the force because of this charge. What is this charge doing? It is attracting. It is the force because of this. Okay. Now if you see the resultant of this is nothing but the parallelogram. So this is the resultant. Okay. So this is basically the force on the unit positive charge that is coming. And that force is called as electric field. call it as electric field. Electric field is also a vector like force. You can write like force on a unit positive charge is nothing but the electric. Okay, so electric field is not a cloud. Electric field is a force. So how do we write down the formula for that for electric field? So we'll write it as we already know have, let us say, this charge. There are two charges are there. Okay. There is one charge which we call main charge plus, okay. And we have kept one unit positive charge. That is one. Two. So we want to find out the force on it. How do we find the force on this? Coulomb force is equal to K into Q1 into Q2 divided by R square. Correct? R is the distance. Now we will substitute K as it is. Q1 is capital Q. Q2 is 1 R. That means then this has become, this is what we call it as electric. Electric field is nothing but the force, is nothing but K Q by R square, and it is in the direction of R 1. So I will write it electric field magnitude is equal to K Q by R. Always remember electric field is nothing but the force, and that force is given by the same Coulomb law, and Kq by R square is the electric. Kq1 Q2 by R square is the force, because since the Q2 is 1 here, we can just substitute it as 1 and we get Kq by R. That's how. Now onwards you remember what is electric field? Electric field is a force. Like that you remember. An electric field is a force. That force, what is the force? Force on the unit positive. That much if you remember, electric field is completely understood. Okay. Now we will only look at how similar to force, electric field can be there because of many charges, not just one charge. Instead of keeping one charge there, I can keep one more charge, Q2. So that will create an electric field here. One more charge will create another electric field. So vectorially, if you add all those fields, you will get the total electric. Total electric field is nothing but vectorial addition. What is the meaning of vectorial addition? Vectorial addition simply means adding using parallelogram law. If you have any difficulties with vector, please do that on your chat, and I will try to give you a certain indication, certain things where you can learn the vector. So when you add vectors, electric field basically is nothing but the addition of at this point. So whenever you have multiple electric fields due to multiple charges, the addition of them is nothing but the total electric field. So we are going to write it more formally using the following formula. Okay, I'll just try to write and get you to that formula. Let us say I want to calculate at point P the electric. So what I will do, I'll have, let's say, Q1, Q2, Q3, like each one of them will contribute certain electric. This electric field contributed by it. Call it as E. This is the electric field contributed by that. I'll call it as E. Because this is the force, repelling force. Yes. This is the electric field contributed. Yes. So vectorially, if I add all these three, EQ1, EQ2, vectorially if I add, how do I add? I add the first two by calculating the parallelogram law, and then I will add this and this by writing one more parallelogram. This is the final equation. Correct? E is nothing but E1 EQ1 plus EQ2 plus EQ3. This is E, correct? So, what is EQ1? KQ1 by R square plus KQ2 by R square, magnitude if you want to find out, plus R1 square, R2 square plus KQ3 by R3 square. So, this is R1, R2, R. Is this correct? Can I add magnitudes like that? Cannot. Why we cannot add? Because if these magnitudes you simply add, you will not get the parallelogram. You have to add them as vector form. So this we cannot write. We can write like this one. Yeah. This is basically nothing but KQ1 by R1 square into R1 cap, like R1 cap plus KQ2 by R2 square into R2 cap plus KQ3 by R3 square into R cap. These are three vectors. One vector, second vector, third vector. If you add all of them, then you are going to get the total. So again, this may look slightly complicated when we write generically, but when we do the actual numerical, this becomes do the numerical and make it as simple as possible. Okay. So today we kind of a quick summary of what we did today is that we actually try to understand what is electric charge. So that is the hero of our story. And we understood electric charge to a great extent because we understand that they repel or attract. Hence, there are two types of charge. Then we understood what are the properties that they can be added, charges conserved. We also saw that charges are quantized. Then we went ahead and understood how the Coulomb's law works. So that completed charges. Then we went to see the electric, and we came to realize that electric field is simply nothing but a force, nothing other than a force. We understood that, and we also understood how to add some of those things, which will be more clearer when you do the. Okay, next we will understand after this electric dipole and electric flux and electric potential. Potential later, electric dipole and electric flux. And after that, actually, there is one more important thing called as Gauss's law. They are very interesting law. Okay. We'll try to understand Gauss's law after. If you do this much, electric field, electric dipole, electric flux, and Gauss's law, we will be finishing the first chapter. And electric potential will come in the second chapter. That time we will discuss that. I would like to complete it, and please write down anything you want on the chat, and next class we are going to clarify any doubts you may have or any kind of